Okay, today we're going to continue to take a look at graphing our radical functions. So we're looking at square roots and cube roots and their graphs. We're going to start on page 3 today. Now we've already done the even numbered problems from page 3. So today we're going to take a look at the odd numbered problems from page 3. So I'm going to start the way that I did last time when we worked through these problems. I want to identify what type of function I'm looking at, give a description of how it's been modified so that I can determine what that equation would look like. So for number 1, since I'm going forever only in one direction, this is a square root function. So I'm looking at the square root of x here, and I know that that key point from when we talked about our parent graphs, that key point is supposed to be at the origin at 0, 0. This is shifted up 1. So I moved up 1 unit. And then I also want to check to see if I have changed the stretch on this graph at all. So the next point should be up 1 and out 1 from the key point. In this case it is, so my only transformation here is that I've moved up 1. To move up, I would expect a +1 outside of the root at the end of my function. That matches equation B up at the top. So graph 1 is modeled by equation B. For number 3, since again we have this sort of end point here, we go forever only in one direction. This is a square root graph again. My key point is not on the origin. I've moved it to the left 2 and down 1, 2, 3, down 3. To move my function to the left 2, I would expect to see x plus 2 underneath the root. Left and right transformations always are grouped in with x. So if it's x in parentheses with something, it would be in parentheses with x. In this case, it's under a root, so it's going to be under the root with x. And then the sign on it is always kind of opposite what I personally would expect. So since we're moving left or back 2, I kind of want this to be a -2, but when it's grouped in with x, it's the opposite sign. I want x plus 2 here to move us left 2, and then to move down 3. When we moved up 1, it was +1 outside of the root. So to move down 3, we're going to do -3 outside of the root. The last thing I want to check is the stretch on this. So from my key point to the next nice point should be up 1 and over 1. It is, so I haven't compressed or stretched this any. So this is the function that I'm looking for. And I do not see that as one of my options up at the top here. So I'm gonna just go ahead and jot this equation down here. Y equals the square root of x plus 2 minus 3. And then finally for number 5, this goes forever in both directions. So this is a cube root of x function. For the cube root, my key point is supposed to be at the origin. This is moved to the right 2 places. And then from my key point to the next nice point should be up 1 and out 1, both up and down. Since those are nice points on my graph, I haven't changed the stretch at all. I haven't stretched or compressed. So I've only moved this to the right 2. Since I'm moving to the right, that's going to be under the root with x and minus, since we're moving to the right. So the cube root of x minus 2, that matches equation A from the top. We're going to continue to work on graphing. We're going to skip past page 4 to page 5 now, and we're going to do a few types of each type of graph on the next several pages. So number 1 on page 5, we've got a square root graph. So I know my parent function would be the square root of x because I have 3 times the square root of x plus 5. The 3 in front here is going to stretch our graph by 3. And then the plus 5 at the end will move us up 5 units. So as I'm thinking about what my graph will look like, we'll make a table here in a second, but that up 5 means I'm going to take my key point and move it up 1, 2, 3, 4, 5. And then that stretch by 3 means my next nice point, instead of up 1 and out 1, will be up 1, 2, 3 and out 1. if you have difficulty with the transformations, you can always make a graph by picking some values for x and plugging them in, making a table. This is always an acceptable way to graph. It's not always going to be your fastest or easiest way to graph, but it is sort of a good fallback. Just remember when we're talking about graphing square and cube roots that the values that I pick for x should be things that are going to have nice square and cube roots, just like the table that we made when we graphed our parent function. So 0 has a nice square root, 1 has a nice square root, 4 also has a nice square root. So those are the types of values I would want to plug in here. Since I'm going to have to take the square root of x, I want to pick things that are going to have nice square roots. So if I plug in 0, that would be 3 times the square root of 0 plus 5. The square root of 0 is 0. 3 times 0 is 0. And 0 plus 5 is 5. If I look at my graph, I have the point 0, 5 already plotted there from our transformation. We took that key point and moved it up 5 units. If I plug in 1, I would have 3 times the square root of 1 plus 5. The square root of 1 is 1. 3 times 1 is 3. 3 plus 5 is 8. And I have that point here as well, 1, 8. If we were to plug in 4, that would be 3 times the square root of 4 plus 5. The square root of 4 is 2. 3 times 2 is 6. 6 plus 5 is 11. So I would have the point 4, 11. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right up there. If I wanted to get that last point with the transformation, remember that that point is normally from the key point out 1, 2, 3, 4, and up 2. But we're saying stretch by 3. So it's normally 2. Multiply that by 3, it would be up 6. 1, 2, 3, 4, 5, 6. Another way I can get that point using a transformation, but a table is fine as well. Let's hop down to number 3. Again, this is a square root, so our parent graph would be the square root of x. The negative in front is going to flip our graph. We'll be flipping over a horizontal axis. And then the -4 underneath tells me I'm going to move to the right 4. So again, I'm going to start by doing this with a transformation. So my key point should be at 0, 0 for the square root of x, but I'm going to move it to the right 4. 1, 2, 3, 4. And then I want to flip this. So my next point should be up 1 and out 1. I'm going to go down 1 and out 1. And then my point after that should be 1, 2, 3, 4, up 2. But since we're flipped, it's going to be down 2. And again, I'm counting from that key point. If I wanted to do this by making a table instead, again, I'm going to pick values that are going to have nice square roots. Now that's a little bit trickier for this one because it's not just x under the square root. So I'm going to start by saying, what do I want the square root to simplify to? What do I want to take the square root of would be another way to think of that. So taking the square root of 0 is going to give me a nice number. Taking the square root of 1 and taking the square root of 4. Those are all numbers that have nice square roots. So I need to pick an x so that I'll get these values under the square root. If I were to plug in 0 right now, I would be taking the square root of -4, which is imaginary. So that doesn't work. I can't plug in 0 for x. But if I wanted to get 4 under the square root, I could plug in 4 for x. So I'm being a little tricky about how I pick these values. If I wanted to get 1 under the square root, what I'm really looking at is what value for x should I use so that this simplifies to 1, the step under the root. Well, 5 minus 4 is 1, so I'm going to plug in 5 for x. And then if I want it to simplify to 4, I would have to plug in 8 for x. So when you're choosing your values for x here, you need to be a little careful. So now let's go ahead and plug these in. This would be negative square root of 4 minus 4. Under the root, 4 minus 4 is 0. The square root of 0 is 0. And then we've got negative 0, but that's just 0. So I have the 0.4 comma 0, which we have from our transformation. Then if I plug in 5 for x, I've got negative square root of 5 minus 4. Under the root, 5 minus 4 is 1. The square root of 1 is 1. So I get negative 1. And we have that 0.2, 5 comma negative 1. And then if I plug in 8, we're saying negative. And then under the root, 8 minus 4. 8 minus 4 is 4. The square root of 4 is 2, negative 2, which again, we have that point from graphing using a transformation as well. So you can graph using your transformations like we did in Algebra 1. You can make a table if you want. Just remember to be careful about those x values that you plug in. Let's continue looking at some of our graphs. So on the next page, page 6, we're going to look this time at some cube root graphs. So for number 5, my parent graph that I'm starting with is the cube root of x. So that's the one that's going to go forever in both directions. And I've modified it by adding 3 to x under the root. So that's going to move me to the left 3 places. So my key point was supposed to be at the origin, but it's going to move to the left 3. 1, 2, 3. And then my next nice points will be up 1 and out 1 and down 1 and out 1. Now we did also have some points that we graphed farther out. From our parent graph, we had the point 8 comma 2. We plugged in 8, took its cube root, we got 2. So if I go 8 out from the key point, I would be up 2. So 1, 2, 3, 4, 5, 6, 7, 8, up 2. And that this way I believe would be off our graph, but we'll see. 1, 2, 3, 4, 5, 6, 7, 8, and down 2. There we go. Just off our graph, but that's okay. And then remember our cube root graph goes forever in both directions. So that's what our graph would look like, graphing using transformations. Now, if I wanted to make a table instead, I could certainly do that. Again, I'm going to need to be careful about the x values that I choose. I want to pick things that will give me nice numbers under the root once I simplify. So I want to pick things that have nice cube roots. I know negative 1 has a nice cube root. So does 0. So does positive 1. So I want to pick x values that will give me negative 1 once I simplify. So x plus 3, I want to simplify to negative 1. This would have to be then for my x value, negative 4. Negative 4 plus 3 would give me negative 1. If I want this now to simplify to 0, I would need to plug in negative 3 for x. And if I want it to simplify to 1, I would have to plug in negative 2 for x. So let's go ahead and do that here. This would be the cube root of negative 4 plus 3. Negative 4 plus 3 is negative 1. The cube root of negative 1 is negative 1. So I should have the point negative 4 comma negative 1 on my graph. 1, 2, 3, 4, negative 1. There it is. If I plug in negative 3, I have the cube root of negative 3 plus 3. Under the root, when I simplify, I have 0, and the cube root of 0 is 0. So I should have the point negative 3 comma 0 on my graph right there. And then when I plug in negative 2, I have the cube root of negative 2 plus 3. Negative 2 plus 3 would be 1. The cube root of 1 is 1. So I should have the point negative 2 comma 1 on my graph. Negative 2 comma 1. There we go. Let's now hop down to number 7. So for number 7, I've got the cube root of x plus 2 minus 1. It's a cube root that I'm seeing here. So my parent graph would be the cube root of x. And then as I'm looking at how this is going to transform, again, I need to pay attention to those numbers that are under the root or outside of the root. So I have plus 2 here. That's going to move me to the left 2 places. And then my minus 1 outside of the root will move me down 1 spot. So my key point, which should be at 0, 0, is going to move to the left 2 and down 1. Now my stretch isn't changed at all. I don't have any multiplier in front of here that's telling me to flip or stretch or compress. So for my next nice points from the key, I'm going to go up and out 1, down and out 1, and then I'll graph those other 2 as well. So from my key, up 2, out 1, 2, 3, 4, 5, 6, 7, 8, and down 2, out 1, 2, 3, 4, 5, 6, 7, 8. There we go. So there's my cube root graph. And again, if I wanted to, I could use a table instead. So if I'm graphing by finding a table, again, I'm just going to have to be careful about those x values that I choose. Now we just did a cube root table. So we know that -1 has a nice cube root. So does 0. So does +1. If I wanted more points for my table, I could pick -8 and +8. Those also have nice cube roots. So as I take a look here, what value would I plug in for x to get this to simplify to -1? Well, that would have to be -3. To get this to simplify to 0, I would have to plug in -2. To get this to simplify to 1, I would have to plug in -1. So I'll do that here. The cube root of -3 plus 2 minus 1. -3 plus 2 is -1. The cube root of -1 is -1. -1 minus 1 is -2. So I should have the point -3, 1, 2, 3, -2 on my graph, and I do. For our next one, I have the cube root of -2 plus 2 minus 1. -2 plus 2 is 0. The cube root of 0 is 0. 0 minus 1 is -1. So I have the point -2, -1. And then finally, the cube root of -1 plus 2 minus 1. -1 plus 2 is 1. The cube root of 1 is 1, and 1 minus 1 is 0. So I have the point -1, 0 on my graph. Just a couple more that we're going to look at on page 7. So we've got some mix here on page 7. Page 5 was all square roots. Page 6 was all cube roots. For page 7, we've got a little bit of both here. So we're going to take a look at just a couple more problems on page 7 to finish up for today. Number 1 on page 7, this is a cube root. So our parent graph would be a cube root of x. Since I'm subtracting 2 under the root, that means I'm going to move this to the right 2. And then the +1 at the end means I'm moving this up 1. So if I graph using a transformation, my key point's supposed to be at 0, 0, but I'm going to move it to the right 2 and up 1. My next nice point would be up 1 and out 1, down 1 and out 1. And if I wanted to extend to those 8s, it would be from the key point up 2, out 1, 2, 3, 4, 5, 6, 7, 8. And then again, from the key point down 2, out 1, 2, 3, 4, 5, 6, 7, 8. There we go. And there's my graph. In my opinion, graphing with the transformation is a little bit easier than the table, but again, you can do either. We just have to be careful with those x values that we select. So things that have nice cube roots, -1, 0, and 1. So the x values I want to pick. What would make the stuff under the root simplify to those things? So if I want it to simplify to -1, I would have to plug in +1 for x. If I want it to simplify to 0, I would have to plug in 2 for x. And if I wanted to simplify to +1, I would have to plug in 3 for x. So from here, I'm going to plug in these values to my function. So I want the cube root of 1 minus 2 plus 1. 1 minus 2 is -1. The cube root of -1 is -1. -1 plus 1 is 0. So I should have the point 1, 0 on my graph. It's right there. And then if I take the cube root of 2 minus 2 plus 1, 2 minus 2 is 0. The cube root of 0 is 0. 0 plus 1 is 1. So 2 comma 1, and it's there. And then the cube root of 3 minus 2 plus 1. 3 minus 2 is 1. The cube root of 1 is 1. 1 plus 1 is 2. So 1, 2, 3, 1, 2. And then finally, we're going to take a look at number 3 on page 7. So we have 2 times the cube root of x minus 1. Our parent graph, again, would be the cube root of x. The 2 in front is going to stretch our graph by 2. And then the minus 1 underneath will move us to the right 1 spot. So my center point is supposed to be at the origin. It's going to move to the right 1. And then for my next nice points, instead of up 1 and out 1, or down 1 and out 1, I need to stretch that by 2. So up 2 and out 1, down 2 and out 1. For my points that are 8 away, they're still going to be 8 away, but instead of being 2 up, they're going to be 4 up because we're doubling. We're stretching that vertical distance by 2. So from the key point, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And then again from the key point, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. There's my graph. Again, if you are more comfortable making a table, you can certainly do that. But we need to, again, be selective about the values that we plug in for x. Cube root again, so I want to use -1, 0, and 1. I could use any numbers that have a nice cube root, but these are always going to be towards the middle of my graph, so they should fit on my coordinate plane. So if I want the stuff under the root to equal -1, I'm going to need to plug in 0 for x. If I want it to equal 0, I have to plug in 1. And if I want it to equal 1, I have to plug in 2. So this would be 2 times the cube root of 0 minus 1. 0 minus 1 is -1. The cube root of -1 is -1. 2 times -1 is -2. So I should have the point 0 comma -2 on my graph, and there it is. And then 2 times the cube root of 1 minus 1. 1 minus 1 is 0. The cube root of 0 is 0. 2 times 0 is 0. So I should have the point 1 comma 0 on my graph. 1 comma 0 right there. And then finally 2 times the cube root of 2. Remember, this is what I'm plugging in for x. 2 minus 1, cube root. 2 minus 1 is 1. The cube root of 1 is 1. 2 times 1 is 2. So I should have the point 2 comma 2. 2 comma 2. There it is. So as you're graphing, again, you can use those transformations, which is how we graph these in Algebra 1, or you can make a table, but you are just going to have to be careful about what you plug in for x, since we're taking cube roots and square roots, particularly with those square roots, since if you take the square root of a negative, you've got something imaginary, which is not a point that we can plot on our plane of real numbers.